ጤና ይስጥልን እንደምን አላችሁ? የስልጠናችን አራተኛውን ክፍል በዛሬው ቪዲዮ ላይ እናያለን። በዚህኛው ቪዲዮ ጂኦፕሮሰሲንግ ኤንድ ኤክስፕሎሪንግ አትሪቢዩት ቴብል ኦፍ ቬክተር ዳታ ኢን QGIS የሚለውን ፓርት እናያለን። እንግዲህ ቀጥታ ወደ ቪዲዮአችን እንሄዳለን። Now in this video I'm going to show you how to geoprocess and how to explore attribute table of vector data in QGIS. So let's continue with this video. The first step is opening the layer in QGIS. So the first step is let's right click on it and you can select properties to check whether the coordinates where the file is saved. This is one way. So here in the information, maybe in your part it maybe look like this one, but you can scroll in this way to the right, this way as much as possible. You can do like this one, and this is one way. Right click on this one and select properties is one way. Other way to get these properties is double click on the file. That means in South Kabale, you can do double clicking and you find this one. Here in the information part, as we have said, the name of the file is South Kabale. The file which was saved in the folder, in my case, it was, as we have said in the previous video, is in the desktop, especially desktop ArcGIS data or QGIS data type. And here is the size, the last modified date, and the lower part information from provided. It is S3 shapefile type, and encoding is window, geometry is polygon, extent is given here, and the coordinate reference system, or we can call most of the time CRS, which was projected coordinate system, UTM zone 37N, unit is meter, and the method is universal transverse Mercator. And these are most commonly used identification of the file, or checking the file is very important part in the information, or we can call general information. In the source part, we can set the layer name. If you want, you can change this one. South Kabale, if you want, you can change this one, or the data source encoding also. This one you can change by clicking on it if you want. And here is the coordinate system. If you want to change it into another coordinate system, you can click here and you can change, or by selecting this one. This is what it was used. EPSG, that means European Petroleum Survey Group code. Most commonly in QGIS used code is this one. That means EPSG rather than coordinate reference system, or CRS. So this is a very crucial part. Here the third part is symbology. If you want to change the colors from here, if you want to change colors, so you can click here and you can change another color. Or if you don't want to see the colors, if you can select here this one, transparent field. So here is no color. And if you want to classify the data layers, you can select here categorized or graduated this way. And leveling is another part. In the leveling, if you want to give the names on the layer, you can select here from no leveling to single level. Then you can select what the value is used to level, maybe the Warada name or the zone name, and region name. If you want, you can select this one and you can level on it. Other, maybe if you want to make a diagram, you can select here pie chart or you can select a histogram or other thing, and then you can select the attribute type, which attribute you use to make the diagram, rendering, size, placement, options, and legends. You can check them. So this is how to check the layer, which uploaded layer. So the layer name is South Kabale. We have already checked the layer where it was saved, what the coordinate reference system, how can we level, how can we symbology change, or how can we change the symbology. These are very important parts when we are doing. The next step is we have to check the attribute table. Now right click on the layer and open attribute table. Here is row part, the ID, region name, region code, zone name, and zone code, Warada name, Warada code, and up to Kabale name and the Kabale codes are given. Now let's select by using the advanced filtering our area of interest. The next step is to select area of interest by using the advanced filtering, by using expression. So let's do. So here in the advanced filtering, we can do like, let's go to the files and fields and values. You can expand fields and values. Then we have to select zone z name, z underscore name is equals to, we can use here is equals to. Then here in the right side you have to use all unique value from zone name. Let me select Dauro. Let me select Dauro, which is one of zone in the south region, and here is no problem. If I have a problem, it shows here the red color or preview is 0, and here is no problem. Now I can do OK. Yes, here the zone, which is Dauro zone in the south region, is selected. Its respective waradas, kabales, and the respective codes are also selected. Here I have selected. Then by using shift I can select the last row, and now I can select only this zone, Dauro zone. Okay, only one zone is selected now. Then let's go to geoprocessing from the vector data. Let's go to geoprocessing tools. Here from geoprocessing tools I can use clip. So what clipping is, I can define clipping. It is an algorithm or geoprocessing algorithm used for extracting the geometries from one layer and used them to cut or clip the geometries from another layer. If I want to clip or extract from other layer, I can use this clipped feature or area of interest. The overlay is this one, South Kabale, and I have to check here only selected features only box for the overlay layer, and I have to save it here, z underscore Dauro. Okay, save, then run. Yes, other part of geoprocessing is dissolve. Let's use dissolve from geoprocessing. Dissolve. So let me define what dissolve is. It is a geoprocessing algorithm that removes boundaries between adjacent polygons that have the same value for a specific or for a specified attribute. So this is the definition for dissolving. Now the input layer is this one, z Dauro underscore Dauro, and the dissolve feature is based on the Warada name. Okay, I can check here Warada name, w underscore name, and okay. Then I have to save it in the workspace where I save, and I have to save it dissolve underscore Tauro. Okay, the save as type is shapefile. It is many, but we have to check it as shapefile. Okay, then I can run it here. Yes, it has dissolved. Yes, you see here only some parts are removed. That means the Kabale parts are removed. You have to consider here in each Warada there are many Kabales. In one Warada you can say 30 or 40 or 25 something Kabale lists are there, but their boundaries are removed, those having the same value for their respective attribute. Then we can take like right clicking it, and we can open here the Warada name. Here the Warada name, zone, and region, and we can find also Kabale names. And now let's do the first step, which is property identification, and we have to specifically go to symbology. We can classify them like this way, classify, and it gives default colors for different Warada, and you can apply this one and you can see the difference here, different colors for each Warada, that means discrete type of colors. And you can also customize the colors. If I want to change this color, I can change here, and I can put like this one, or that means dark blue. Or you can add also the boundary colors, or you can also remove the boundary colors. Okay, like this one, Sarah. Okay, this way you may change the color, and you can remove the boundary or stroke color, like transparent color stroke. Okay, this one also can be changed like this, and you can change the stroke color. This one is the boundary color in other software for GIS, but like this one. Okay, here is change this one, the color also. Again, no need of color, or you may single symbol, and you can change. Okay, and you can add size, then apply. Here is. You can visualize here from the OpenStreetMap. Okay, other thing we can do labeling. Here we can label single levels, and we have to select Warada name, and maybe you can customize the sizes, font size, or the colors. You can apply like this one here. Araka, Ganna, Tucha, Sara, Loma. If you want to remove, you can do like this here, or you can do right click and remove layer option is here. Okay, you can show like this one by using XYZ tiles, and we can visualize the regions where each worada belongs to. Thank you very much. See you in the coming video.